Hi everyone, welcome back to another video of Unported Academy. So guys, in our previous videos we have been learning about the pumps. We have seen the centrifugal pumps, we have also seen the reciprocating type pump. Well guys, over here in this today's video we are going to learn about the another positive displacement type pump, that is nothing but the gear pump. So guys, first of all let us understand what is the exact meaning of the positive displacement type pump. Well, in this type of the pumps, like a certain amount of the liquid gets entrapped into the casing or else into the cylinder, and that particular fixed amount of the fluid gets forcefully pressurized, and then that fluid will get delivered through the discharge to the delivery pipe. Well, this is nothing but the working of the positive displacement type pump, and whenever someone will ask you what is the positive displacement type pump, so here it is. So guys, over here in today's video we are going to learn about the gear pump, its different types of the gear pumps, its construction, working, and some of the applications. Alongside will be also seeing the certain limitations of the gear pump. This video is going to be so informative, please watch it till the end. And guys, if you are new over here on my education channel Unported Academy, kindly subscribe it, because that's absolutely free of cost, and please press the bell icon, so whenever I upload a new education informative video you will get instant notification. So guys, without wasting any time, let's begin with our today's topic, that is the working construction of the gear type pump. So guys, when we talk about pump, the first thing that comes in our mind that it is a device which will pressurize the fluid, which will suck the fluid from the inlet, and it will pressurize it, and then it will discharge it with the higher pressure. Like it will pressurize the fluid and it will ultimately transfer the fluid from one location to the another location. Well guys, these pumps will be having the different types, like and over here in this video we are going to learn about the gear type pump. Well, when we hear about the gear type pump, the first thing that comes in our mind, that is the gears. It uses the rotating gears. The gears can be of the spur gear, helical gear, herringbone gears. So these are the different designs of the gears that can be used in this gear pump. So let us understand what is the principle of the gear pump. So over here, this particular gear pump is like uses two circulating gears. These particular two gears are mounted on two different shafts. The one gear is the driven gear and the second gear is the driving gear over here. So when this particular two gear starts rotating, the suction will get created at the inlet of the pump, so that the liquid will enter into the pump. That particular liquid will get pressurized against the cavities between the teeth of the rotating gears. So that particular fluid will get pressurized between the two rotating gears, and that particular pressurized fluid gets delivered from the outlet to the discharge pipe. So that is nothing but the overall working of this gear pump. So guys, over here the main important parameter that we need to understand this is this particular gear pump works on a closed tolerances. Like there has to be the closed tolerances which needs to be maintained between the gears and the casing in order to generate the higher pressure. So if there is not enough tolerances between these two gears and the casing, we won't be able to generate the required pressure at the outlet of the pump. So this is the reason this closed tolerances needs to maintain in the gear pump. So guys, there are two different types of the gear pump, that is nothing but the external gear pump and the internal gear pump. This particular external gear pump is very frequently used along with the industries, and the internal gear pump, that is the specialized arrangement of the gears. So guys, first let's understand what happens in the external gear pump. So guys, as we have seen earlier, the two gears, these are mounted on a two different shaft that is supported by the bearings. So this is the representation, that is nothing but the external gear pump. So over here at the inlet of the external gear pump, the gears which are continuously meshing with each other, at the inlet side they came out of their meshings, and the expanded volume gets created at the inlet side of the pump. So due to that particular expanded volume, the liquid gets entered into the pump and the suction will get created, a pressure difference gets created over here. So this is the reason the liquid will enter in the pump. The liquid will move from the cavities, that is from the teeth of the pump, and it will move alongside the casing as well. As the gears will continue to rotate against the pump casing, the liquid gets forcefully pressurized at the uh, outlet of the pump. So over here the trapped fluid will move around the casing from inlet to the outlet, and this will ultimately increase the pressure in the fluid. As over here at the discharge side, the two gears will again interlock with each other. The expanded volume that we will be getting at the inlet side, the opposite side, the volume will get reduced, and due to that reduction in volume, the fluid will then pressurized, and fluid will forcefully thrown out of that particular casing from the discharge pipe, and ultimately over here we will be getting the higher pressure at the discharge side. Also guys, over here due to the continuously rotating action of the gears, the fluid will get entrapped into the casing and it will move against the casing. So this will also increase the pressure in the fluid itself, and the liquid is thrown out with a higher velocity and higher pressure. So guys, this is nothing but the working of the external type gear pump. And over here, once the fluid gets transferred from the suction side to the discharge side, the fluid cannot again move to the suction side. So this makes this type of the pump as a positive displacement type pump, so that that particular liquid which is there in the casing cannot be recirculated. So this is the reason it is called as the positive displacement type pump. And in this type of the pump, we will be getting the continuous discharge, we will be getting the pulsed free flow, like will not be getting the intermittent flow that we are in case of the reciprocating type pump. We will be getting the intermittent flow, but over here we will be getting a pulsed free flow, we will be getting a continuous discharge. So guys, now let's talk about the second type of this gear pump, that is nothing but the internal gear pump. This type of the internal gear pump works on the same principle as that of the external gear pump, but it is having the design is quite different than that of the external gear pump. Over here in the case of the internal gear pump, the two different gears, that is the one is the internal gear, that is the driven gear, and this particular internal gear will be having the teeth projecting inside. The second gear, that is the driven gear, that particular driven gear is continuously in meshing with the internal gear, and that particular driven gear is placed eccentrically, as you can see over here in this particular image, and over here a void is created. To avoid that particular void, a spacer which is used, and that particular spacer is fitted in that particular internal gear pump. The main function of this spacer is to reduce the area, to occupy that particular area, and to increase the pressure in the fluid, and to maintain a close tolerances. So guys, in any of the gear pumps, the close tolerances are always essential, and it is always necessary in order to create a pressurized fluid. So guys, let's just talk about the working principle of this internal gear pump. So as the internal gear pump starts rotating, the gears will came out of the meshing, and it will create the expanded volume. The pressure difference gets created, the liquid will get flow inside the internal gear pump, and that particular liquid is again then forcefully rotated between the meshing of the gear and between the spacer. So over here there is a small clearance between the gear and the spacer. The liquid will flow from that particular cavities, from that particular clearance, and then the liquid is forcefully thrown out from the discharge or from the outlet. So at the discharge side, the gears will again interlock with each other, and so over here the area will get reduced, so that the liquid will get forced out from the outlet over here, and we will be getting the pressurized fluid. So this is nothing but the working of the internal gear pump. So now let's talk about some of the main features of this gear pump. So over here, this type of the gear pump will be having a compact design, and the design is very much simple. Over here we will be having the less number of the moving parts. The pressure which gets developed over here is less than that of the reciprocating pump, but it is more than that of the centrifugal pump. The flow rate will be less than that of the centrifugal pump, but it is more than that of the reciprocating pump. We will be getting the pressures up to 210 bar, that is equivalent to 3000 psi. The material of the construction which is used in this type of the pump, that is mainly cast iron or else stainless steel. So guys, this type of the pump is mainly suited for the aggressive liquids. Also the liquids will be having the higher viscosities. Also it is suitable for the corrosive liquids such as sulfuric acid, sodium hydrochloride, ferric chloride and sodium hydroxide. So guys, over here there are some kind of the limitations in the case of the gear pump, such that the gear pump needs to be lubricated after a regular interval of time, or else the pump should not run dry. If the pump will run dry, so in that particular scenario the wear and tear of the rotating parts will occur, and this will result in the failure of the pump. Also it does require the strainer, because the solid particles will get entrapped in that particular strainer. The volumetric efficiency of this type of the pump gets reduced at the lower speeds. A gear pump should not operate too far from its recommended speed. Also the gear pumps will be having the specific temperature range. So as the temperature increases, the thermal expansion will occur in the rotating parts of this gear pump, and then it will reduces the clearances within the pump, and ultimately it will increase the wear and tear and causes the pump failure. The main disadvantage of this type of the pump will continue to operate against the back pressure. So it is always recommended to use a safety valve or else the pressure relief valve. So guys, now let's talk about some of the applications of the gear pump. This type of the gear pump is mainly suitable for the higher viscous fluid such as oils, resins, and this is the reason it will be having the higher industrial use. This type of the pump is used where the accurate dosing and the high pressure is the requirement. The accurate dosing means that continuously or as the continuous flow. It is used in the chemical mixing or as blending operations, industrial, agricultural, resins, polymers. Also it is used in the chemical processing, food processing units, alcohol solvents, soap manufacturing. So guys, these are some of the applications of the gear pump. So guys, I hope you understood the today's topic of the gear pump. We have seen the working of the gear pump, its different type, some of the limitations and its application. So guys, I hope you like my video. If you having any doubts, any queries, please leave a comment and please do subscribe to my educational channel Engineers Academy. Thank you so much guys for watching this educational video.